Welcome back to Zern Squad. Let's see who we're working with today.
I'm Zeph.
I'm Milan.
And we're in the Zern Squad.
Today we will solve a two-part word problem about a rectangular planter, which is a box for plants to grow in. Let's start with part 1. Read the problem and imagine what is happening. Read and imagine what is happening in this problem. Jeffrey wants to make a rectangular planter that extends from the ground to just below his back window. The window starts 3 feet off the ground. 1. If he wants the planter to hold 36 cubic feet of soil, name one way he could build the planter so that it is 3 feet tall. Explain how you know. Note, assume all of the dimensions are whole numbers. What does Jeffrey want to do? So Jeffrey wants to build a rectangular planter under his back window. He wants the planter to hold 36 cubic feet of soil, so that's how much space the planter will take up. In other words, 36 cubic feet will be the planter's volume. What else does Jeffrey need to figure out before he can build this planter? What else does Jeffrey need to figure out before he can build the planter? Which dimension does Jeffrey already know? Reread the problem. What will be the height of Jeffrey's planter? Jeffrey wants to make a rectangular planter that extends from the ground to just below his back window. The window starts 3 feet off the ground. 1. If he wants the planter to hold 36 cubic feet of soil, name one way he could build the planter so that it is 3 feet tall. Jeffrey needs to figure out what the planter's dimensions will be. We already know the height will be 3 feet, so that the planter will extend from the ground to just below the window that is 3 feet higher than the ground. Let's show this. Trace over the prism in your notes to represent Jeffrey's planter. Label what we know and use a question mark for the parts we don't yet know. Solve this in your notes. Jeffrey wants to make a rectangular planter that extends from the ground to just below his back window. The window starts 3 feet off the ground. If he wants the planter to hold 36 cubic feet of soil, name one way he could build the planter so that it is 3 feet tall. Explain how you know. Trace over the prism to represent Jeffrey's planter. Then, label what we know and use a question mark for the parts we don't yet know. We can draw a rectangular prism to represent the planter. We can label the height. It's 3 feet. We don't know the length or the width yet, so we can label these dimensions with question marks. And the volume is 36 cubic feet, so we can label that here. Check your work. What is the problem asking us to figure out? The problem tells us to name one way Jeffrey could build the planter. In other words, we need to figure out what Jeffrey can make the other dimensions so that the planter will meet his needs. Solve in your notes to show how Jeffrey can make his planter. Make sure to explain how you know. Solve for the other dimensions. Then explain how you got your answer. Note, assume all of the dimensions are whole numbers. It's time to talk to the Zern Squad about their strategies for solving. What did you try, Zeph?
I know volume is length times width times height. We know the planter's height is 3 feet, so I used guess and check to help me solve for the missing dimensions.
That works. How did you approach this, Milan?
I thought of the volume as area times height. I solved for the area first, then figured out the length and width.
Nice idea. Remember, it's okay if you solve differently than the Zern Squad, as long as you explained how you got the correct answer. So, which explanation do you want to hear?
I already knew the volume and the height of the planter, so I put those numbers in my equation. Then I had to figure out the length and the width. I used guess and check to see what numbers I could multiply to get 36. 36 is a pretty low number, so I thought I should multiply 3 small numbers. First, I tried 2 times 2 times 3. That equals 12, which is way too low. So next, I tried 4 times 4 times 3. And I got 48. That's a little too high. So then, I tried 4 times 3 times 3. That equals 36, which is the volume Jeffrey wants. Now, I need to explain my answer. I knew Jeffrey wanted to build a planter with a height of 3 feet and a volume of 36 cubic feet. I used volume equals length times width times height and figured out that the length could be 4 feet and the width could be 3 feet.
Nice work. Zeph showed you one of the correct answers. A prism with a height of 3 feet and length and width of 6 feet by 2 feet, or 12 feet by 1 foot, would also be correct. Check your work. Note, 6 feet and 2 feet, or 12 feet and 1 foot are also correct for the length and width.
I already knew the volume and height of the planter, so I put those numbers in my equation. Then I used this equation to find the area. I divided 36 by 3 and got 12 square feet. So any two numbers that would give me that area would work for the base of Jeffrey's planter. I used 4 and 3 since 4 times 3 equals 12. I could have also used 6 and 2 or 12 and 1, since they have a product of 12 too. Now, I needed to explain my answer. Since Jeffrey wants to build a planter with the height of 3 feet and a volume of 36 cubic feet, the base of this planter should have an area of 12 square feet. I drew a planter with the length of 4 feet, a width of 3 feet, and the height of 3 feet.
Nice job on part 1. Now let's expand on what we've done. Read part 2 and imagine what is happening. Jeffrey wants to make a rectangular planter that extends from the ground to just below his back window. The window starts 3 feet off the ground. 1. If he wants the planter to hold 36 cubic feet of soil, name one way he could build the planter so that it is 3 feet tall. Explain how you know. 2. Jeffrey needs another planter that holds double the volume. Should he double all of the dimensions? Explain why or why not. Include a drawing in your explanation. Jeffrey wants the new planter to have Jeffrey wants to double the volume. Reread the problem. Which expression will help you find the volume of the new planter? Jeffrey wants to make a rectangular planter that extends from the ground to just below his back window. The window starts 3 feet off the ground. 1. If he wants the planter to hold 36 cubic feet of soil, name one way he could build the planter so that it is 3 feet tall. Explain how you know. 2. Jeffrey needs another planter that holds double the volume. Should he double all of the dimensions? Explain why or why not. Include a drawing in your explanation. Reread the Jeffrey wants to make a new planter that will have double the volume of the first planter. So double the volume, or 36 times 2, is 72 cubic feet. Should he double all of the dimensions to get this new volume? Solve in your notes, and make sure to explain your answer using words and a drawing. Record the equations and solve. Then explain your answer using words and a drawing. Check your work. Should he double all the dimensions? Why or why not? There are a lot of different ways to approach this problem. Let's see 2 of these ways. What did you do, Zeph?
I decided to double the dimensions and solve for this volume. That way, I could see if it was equal to 72 cubic feet.
Good thinking. How did you solve, Milan?
I drew a second identical prism to show what it looks like when we doubled the value. Then I used this to help me think about what the question is asking.
Which explanation do you want to hear?
I wanted to figure out if doubling the dimensions would be the same as doubling the volume. First, I made a new prism to show what this would look like. I doubled the length. 4 times 2 is 8. Then the width. 3 times 2 is 6. Then the height. 3 times 2 is 6. And drew a prism with these dimensions. I thought that this seemed to be more than double this volume, but I multiplied just to be sure. I solved 8 times 6 times 6. And got 288 cubic feet. That's way more than double the volume. So, Jeffrey should not double all of the dimensions, because if he doubles all of the dimensions, the new volume will be larger than he needs.
We know Jeffrey wants to double the volume, so I drew 2 of the prisms next to each other to represent 2 times the volume. And I realized that I only doubled 1, not all 3 of the dimensions to get double the value. I checked my work by multiplying the new dimensions. 8 times 3 times 3 equals 72 cubic feet. So my answer checked out. Jeffrey should not double all the dimensions. He only needs to double 1 dimension in order to double the volume.
Way to work through some tough problems about volume. Now, show what you know in the Tower of Power.